What's up, guys? Xavier Elon here. Today I'm going over single number. It's an easy solution on LeetCode. Please subscribe to my channel if you haven't already and hit that like button. It helps the YouTube algorithm so my channel can grow. So yeah, today I was learning about reviewing hash maps, and I decided to work on some hash map problems, so I'll be going over some of those. So this one reads, given a non-empty array of integers, every element appears twice except for one, find that single one. And their note is, so this is like their challenge, you should have a linear runtime complexity. Could you implement it without using extra memory? So when I saw that, I was like, obviously it's possible, so we should definitely do it that way. It's the most impressive way. But I'm going to show you guys two solutions. One is hash map, which obviously it's not going to be, it's going to use extra memory. But I'm going to show you guys the other way, which is doesn't use extra memory, which is has to do with electrical engineering a little. It's very low level stuff, but both use linear runtime. So this is very easy description. I shouldn't have to explain it. The answer is 4 because it just appears once, 1 because it appears once. So let's go over the hash map solution first. So we have a hash map. So remember, hash maps have a key and then a value, and I'm just going to name it map new hash map, and we're just going to loop through nums, and we're going to store the values in the map. So map.put I, so this is the key. So for that key, we're going to use the map.get or default. I had to refresh my memory on this function. I had to look it up again, kind of forgot how it worked. So the way it works is you have if, so it's telling the hash map to look up this value I. So I, in this case, in the first case it would be 2. The first time it's not going to have it, so it's going to say put the default value there. Well, we're going to put 0, but we're going to put +1 at the end, because in the second case we are going to have a 2 and the value is going to be 1. So it's going to say grab that value and put it there and return that value. But we're going to add 1 to it this time. So we're basically updating our map, counting. That's how we count how many are in the array, basically. And so that's that for that for loop. Then we have a second for loop. So if map.get, so we just need to get I. So we want to grab I. We're gonna, if the value at I equals 1, so that's basically saying there's only one value there, then we return I. So hopefully that makes sense. Let me see if I can explain it better. It's saying get the key I, and if the value, which is this integer, which is what we're putting here, is 1, return it. So that it means that's the one that is, there's only one of that value. Otherwise we're going to return 0. So let's just run that. Perfect. It's not very fast. So I'm going to show you guys the other way now, which is more impressive. This has to do with electrical engineering. If you guys have learned about electrical engineering at all, it's bit manipulation. So let me zoom in again. Okay, so I recorded my solution and explanation for the XOR and realized I made a few mistakes. I just feel like I didn't explain it well, so I'm re-recording. So the XOR solution is, it's electrical engineering topic. It has to do with bit manipulation. So this is for like logic boards. This is the logic symbol for it. If I don't know if you guys are familiar with that. I learned it in some of my electrical engineering classes. Also, it is this symbol, the plus. So where is the tab? So I'm going to show you guys on my iPad real quick. So this is actually supposed to be a plus. I drew an X. So this is the symbol. So if we do one exclusive or means exactly what it sounds like. It means exclusively or. So 1 or 0 is going to be 1 because it's exclusively or 1. If you did 1 or 0, it would still be just 1. So it's a little bit different than exclusive or just regular or. If you do 1 exclusive or 1, it's 0. But if it was just or, it would be 1 because it can be both or neither. The only way or is false if it is 0 or 0, which is 0. But let's just stick to exclusive or. That's like a whole nother topic. So when you get to bigger numbers like 4 and 2, you have to convert them to binary. So let's convert 4 to binary. It's 1 0 0. Hopefully you guys know binary. 1 0. 2 is 0 1 0. Make sure you put the leading 0. That's where it's easy to make mistakes. So let's go through this. If you do exclusive or, there's only one 1 in the first place, so we put a 1 there. The second one is they're exclusive or as well because there's a 0 and a 1, but in the third one they're both zeros, so we're going to put 0 because they're the same. So we get 4 plus 2 is 6. So 4 exclusive or 2 is 6. So I'm going to code it out real quick. So int I equals, we're going to set it equal to 0. So, and then we're just going to loop through nums, and we're going to do the exclusive or all the way to. So so I equals, so the symbol for exclusive or is the caret symbol. So I exclusive or n, and then we just need to return I. So let me explain why this works because it may not make sense at first. Basically what's happening is, let me write out my test case that I created for this problem. Oh, they erased it. Okay, anyways, if we do, well, let me just write a new one. 2, 3, 4, 3, 4. So I'm going to write that out on my iPad. 2, 3, 4, 3, 4, 2, 1. So basically how it's going to work is, since we're doing exclusive or, these all the numbers that are the same are going to cancel out, regardless if we match them up at first. So let me show you real quick. If we do 2 exclusive or 3, so we have 1 0 and 1 1. The exclusive or for this is 1, or no, it's 0 1, which is 1. So we have 1 remaining basically. We go to the next one, so we have 3 exclusive or 4. Well, actually no, we have 1 because we have to keep the 1 that's left over. So 1 exclusive or 4. It's basically going to cancel out all the same numbers because you're breaking the numbers down into single ones. So we're going to cancel out all those ones, and whatever is left is going to be our answer. So because we're breaking them all down into binary, so 4 is just 1 0 0. This is just 1. Let's add our leading zeros. Exclusive or, so we have 1 and 0 and then 1, so that's 5. So now we have 5 exclusive or 3. So let's draw out 1 0 1 exclusive or 0 1 1. That gets us 1 in the first place, and then 1 as well, and then 0, so we get 6. And then we're back to 4, so 6 exclusive or 4. So we have 1 1 0 and exclusive or 1 0 0, so that gets us 0 1 and 0, which is 2, and then it's 2, I don't know why that is, 2 exclusive or 2. Obviously those just like cancel out. It's exclusive or, we're going to be return 0, and that leaves us with 0 exclusive or 1, which is just going to be 1, so we get the right answer there. So that's why that works. You got to think of it as like on a bitwise level. We're breaking it down into just single ones. So that's why that works. It helps to take electrical engineering classes, but you don't have to, obviously. So this one works a lot faster. If I can zoom out, yeah, it gives us 100%. So that's the explanation for that. Hopefully that makes sense. First time I tried recording it, I didn't explain it very well. Hopefully that time it worked a lot better. Thanks for watching.